We're going to be looking at upthrust and Archimedes' principle. If we were to push down on an ice cube to the bottom of a glass of water and then release the ice cube, then the ice cube would rise to the surface. Now, why would it do that? And that's because the water is exerting an upward resultant force on the ice cube, and this force is called the upthrust. Upthrust arises due to a fluid exerting a pressure on an object that is placed in it. The resultant pressure on the sides of the object is zero, but as pressure increases with depth, the pressure that the fluid exerts on the lower surface of the object is greater than that on the upper surface. And this pressure difference results in a net upward force that the fluid exerts on the object, which is called the upthrust. Archimedes' principle states that when an object displaces a fluid, then the upthrust is equal to the weight of the fluid displaced. So this is representing the volume of fluid that has been displaced by the object, and the weight of this fluid is equal to the upthrust which is acting on the object. We're now going to go through the proof of Archimedes' principle. It's not a proof that you need to know for the exam, so it's for those who are interested. So here we have an object which is fully immersed in a fluid, and the fluid exerts a force of F2 on its lower surface and a force of F1 on its upper surface. And so the resultant force, F2 minus F1, will equal the upthrust. So force equals the pressure times the area, the surface area that the force is acting on. So the upthrust will equal the pressure difference multiplied by the area of the lower surface or the upper surface of the object. Pressure increases with depth, and so pressure equals the density of the fluid times the acceleration of free fall times the depth. And so the pressure at the upper surface, P1, will equal rho g H1, and the pressure at the lower surface will equal rho g H2. And if we substitute for P1 and P2 into the equation for upthrust, we get this. And the volume of the solid is equal to the volume of the fluid displaced, and that volume would equal the area of the lower surface multiplied by the height of the object. So it's area A times by H2 minus H1. So we can substitute for volume into the equation for upthrust to give us rho GV. And the mass of the fluid displaced is equal to its density multiplied by its volume. So the upthrust will equal mg, that is, it will equal the weight of the fluid displaced. For an object that is floating in a fluid, then the weight of the object will equal the upthrust. And from Archimedes' principle then, as upthrust equals the weight of the fluid displaced, then the weight of the object will equal the weight of the fluid displaced. So this is representing the volume of fluid that is displaced by the object, and its weight is equaling the weight of the object. So the law of flotation states that a floating object will displace its own weight in a fluid. So for a floating object, the weight of the object is equal to the weight of the fluid that is displaced by the object, and as weight equals mg and mass equals density times volume, then we can say that the mass of the object times g equals the mass of the fluid times g. And so the volume of the fluid that is displaced is equal to the volume of the object that is submerged. So we call that VOS, so the object that is submerged in the fluid. If we substitute that into this equation, we get this, where the g's has cancelled. And if we rearrange the equation to get the volumes on one side and the densities on another, we can see then the fraction of the volume of the object that is submerged in the fluid is equal to the density of the object divided by the density of the fluid. So an object with a higher density will have a greater fraction of volume submerged in a fluid, and that's because floating object will displace its own weight in a fluid, so it has a greater density, it will have a greater weight, so it will displace a greater volume of fluid. And if you have an object that is submerged into a fluid of higher density, then a smaller fraction of its volume will be submerged. And that's because a floating object will displace its own weight in a fluid, so a fluid of higher density to displace the same weight needs less volume. And finally, if we consider an object that is sinking in a fluid, then that means that the weight of the object must be greater than the upthrust. And we know from Archimedes' principle that upthrust equals the weight of the fluid that's been displaced. So for an object that is sinking, the weight of the object must be greater than the weight of the fluid displaced, which means that the mass of the object must be greater than the mass of the fluid that has been displaced. And when an object is fully submerged, then its volume is equal to the volume of the fluid that's been displaced. And as mass equals density times volume, and they both have the same volumes, then that means that the density of the object is greater than the density of the fluid. So for an object to float, then the density of the object must be less than the density of the fluid.